Well, why does a copper wire conduct electricity? It's because the copper wire, it has free electrons, and the metallic conductivity is due to the drifting of those free electrons. But how about a solution of NaCl, huh? How about a solution of NaCl in water? How could it manage to conduct electricity? So that's called electrolytic conductivity, and that's what I'm going to talk about right now. So let me start off with electrolyte. What are electrolytes actually? So these are the substances which can conduct electricity in molten state or in aqueous state. So basically, if I have a solution of NaCl, then that's going to be a good conductor of electricity. Or I could also have that NaCl in molten state. Like if I heat NaCl up to 800 degrees Celsius, then that's going to be converted into molten NaCl. And that molten NaCl can as well conduct electricity. So yeah, how many categories of electrolytes are there? There are actually two categories. The first one are the strong electrolytes. Now these strong electrolytes, they can undergo complete ionization in their aqueous state, while the weak electrolytes, they only undergo partial ionization in their aqueous state. To name a few, the strong electrolytes, HCl, that's hydrochloric acid, sulfuric acid, these are the strong acids. All the strong acids are strong electrolytes. And the strong bases like sodium hydroxide and potassium hydroxide, and almost all the salts, these are the strong electrolytes. And the weak electrolytes, that includes all those substances which undergo partial ionization, as I mentioned earlier. And to name a few, that's S3PO3. I think that's hypophosphoric acid or something. I don't actually remember the name, so you could look up yourself. And that's HCN, hydrogen cyanide, and acetic acid, or even ethanoic acid. Yeah, and you gotta keep in mind that all the organic acids, these are weak electrolytes. Now let's talk about the factors that affect electrolytic conductivity. So first of all, I would like to show you a demo how these strong electrolytes, they undergo complete ionization in their aqueous state. I have here a cup of NaCl, so I'm going to add a little bit of water, and that is going to completely dissolve in there. So let me just do that. It's all dissolved except for that little at the base, but I didn't bother to bring a spoon, so it's already dissolved. And what I want you to realize is that this is an aqueous solution of NaCl, and inside this aqueous solution there are gonna be the ions, and that's Na plus and Cl minus. Sodium and chloride ions, they are separated because the interaction between the ions, it decreases. You must have read in electrostatics about the impact of a dielectric medium, the impact on the electrostatic force of attraction due to a dielectric medium. So if I insert water, there will be, the electrostatic force of attraction between Na plus and Cl minus, that's going to decrease, because the permittivity of water is like 80 times more, so that's going to decrease. Okay, we'll talk about that later in electrostatics, but I just want you to realize that when I introduce water, the electrostatic force of attraction between Na plus and Cl minus decreases, and they're going to break into ions basically. So that's it. So what are the factors that affect conductivity? The first factor is the solute-solute interaction. Now that's also called interionic interaction, and you probably know that the like charges, they repel, and the unlike charges, they attract, and that's why there is interionic interaction. Just keep in mind that the conductivity of dilute solution is more, because the interionic distance in case of dilute solution, that's more, because I just pour in a lot of water here. I just want to do it right now. So I'll add a bit more water so that the conductivity of this solution is going to increase. So if the conductivity right now is say X, then after I add a bit of water, there you are. Okay, so the conductivity of this solution will increase, because what I did was I decreased the inter-ionic distance between the Na plus and Cl minus ions. Oh my god, whoops. Alright, so yeah, probably you will remember that your whole life, because I'm doing a lot of this crazy stuff right now, because that's gonna make sense. Okay, you will remember that. So yeah, inter-ionic distance is increasing, and the conductivity is also increasing, because the ions, they are not going to interact if they are far away from each other. But if they were to be close, as in the case of concentrated solution, then due to interaction the speed would decrease, and hence the conductivity would also decrease. And the second factor that affects the conductivity of an electrolytic solution is the solvation of ion. Now there is also interaction between the solute and solvent particles. So what I just took here was a solution of NaCl, right? So what you gotta keep in mind is that larger the size of particle, lower will be the speed. Okay, if you have a larger particle, then the speed will definitely be less. So if you have studied the structure of water, then you can say that this oxygen here has a partial negative charge, while these hydrogens, they have partial positive charge. So that's my Na plus ion. This plus, big plus in the middle, that's my Na plus ion, and this Na plus ion will be surrounded by water molecules from all the side, right? So it forms a hydration sphere. So if this Na plus wants to migrate up to this electrode, that's cathode, negatively charged, if it wants to migrate up to here, then it has to move itself as well as these guys around himself. Okay, so this whole hydrogen sphere should be able to reach this electrode, and that's how the conductivity is affected. Larger the size of particle, lower will be the speed, and if the hydrogen sphere is large, then the speed of the particle will be less. Alright, the mobility of the ion will be less, and the conductivity decreases. So here's a very nice question. The first time I saw this question, I was like, whoa, that's pretty easy. I could. So since K plus is from the fourth period, I could say that it's the largest, and since it is the largest, it will have a lot of water molecules surrounding it. So yeah, of course, potassium is going to be the largest, so and lithium is going to be the smallest, and the conductivity of potassium is going to be the least, while that of lithium is going to be the most. But I was dead wrong. And this is the type of question they ask in the competitive exams. Alright, so what you gotta keep in mind is that hydrogen energy is going to be more for smaller cations. In that case, yeah, I was right that potassium is the largest cation, but that does not necessarily mean that it will also have the largest hydrogen sphere. In fact, hydrogen energy is maximum for smaller cations, so they are going to have a larger hydrogen sphere. So in that case, lithium will have the largest hydrogen sphere, while potassium will have the smallest hydrogen sphere. That's just the opposite. And yeah, that's how the conductivity is affected. Potassium will have the highest electrical or electrolytic conductivity, because it is the smallest guy, including all these water molecules, while lithium, since it is the smallest cation, it's going to have the largest hydrogen sphere, and that is going to have the smallest electrolytic conductivity. And last one is the effect of temperature on electrolytic conductivity. If you increase the temperature, all those interactions, ionic interaction and this solute solvent interaction, both of them are going to decrease, and of course that means the electrolytic conductivity will increase. And that probably wraps the thing.